Welcome to Algebra 2, Target 40. I can graph a basic trig function. We're going to be looking at the three basic trig functions of sine, cosine, and tangent, the graphs of those three functions in Target 40. In this first part of Target 40, we'll be focusing just on sine and cosine. So if we take a look at what sine and cosine graphs look like, you can see them down here at the bottom. And if you notice, the first thing you should notice is that they look very much the same. So if I take a section of this graph right here, and this is the sine graph, and if I move that over on to the cosine graph, you can see that it matches up perfectly. Okay, and that's one thing that we want to notice about sine and cosine is that they're essentially the same exact graph. Okay, they're just shifted over by 90 degrees, or pi over 2 units. Okay, you can see here, let's take this back. If I draw the axes, or the y-axis on this, it's right here. Okay. And if I take both of those together now, and drag them over, you can see where it lines up here. Okay, the y-axis is just moved over pi over 2 units to the left. Okay, so it's just a translation. It's just a sliding of the graph pi over 2 units. All right, so that's the first thing that we want to notice about sine and cosine graphs is that they're essentially the same. Now, talking domain and range, okay, up here. Okay, domain is all the values that we can find sine and cosine of. Well, there are no values that we can't find the sine or cosine of. So the domain is going to be all real numbers, and that's for sine and cosine. All real numbers will always be the domain. And then the range is always going to be from -1 to 1. Okay, and again, the reason that is if you think back to our unit circle that we just talked about in the last target. If we have our unit circle, okay, this is 1, right? This is -1, right? This is 1, and this is -1. Okay, so the values of x and y here are never going to go outside of 1 or -1. Okay, never going to get higher than 1 and never get lower than -1. So that's why the range is from -1 to 1. Now, amplitude of a function's graph is going to be half the difference between the maximum and the minimum. So in this case, since the maximum is 1 and the minimum is -1, the difference between those would be 2, and half of that is 1. So the just parent function y equals sine of x and y equals cosine of x, okay, the amplitude is just going to be 1 always. As we start looking at graphs with different amplitudes, okay, we'll have different values for that. Now, these functions are what we call periodic graphs because they are repeating. They have a repeating pattern. And you can see that it just looks like a wave. It just goes up and then down and then up again and then down again and then up again and then down again. And it's just going to continue on like that forever and ever. So that repeating pattern makes this a periodic graph. Now, when we have a periodic graph, the shortest repeating pattern is what we call one cycle. So if we look at our sine and cosine graphs, okay, one cycle, if we start with the sine graph here, one cycle, if we start at the y-intercept, okay, we're going to go up, back down, and then back up to where we started. Okay, so that would be one cycle. Now, the length of a cycle, okay, is what we call the period, okay, of the graph. So since we start here at 0, okay, and we end that cycle at 2 pi, the period is going to be 2 pi units. Same thing is going to be true here over at cosine. Okay, if we start here at 0, okay, we're going to go down and then back up, okay, back to our maximum. Okay, and again, you can see that the length of that cycle is going to be 2 pi units. Now, x-intercepts for these graphs, you notice that they repeatedly cross the x-axis, right here, 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 right? And then they're just going to continue to cross that x-axis over and over and over again. So x-intercepts for the sine graph occur at every multiple of pi. So at 0, at pi, at 2 pi, at 3 pi, 4 pi, 5 pi, 6 pi, and then also the negative multiples of pi as well. So negative pi, negative 2 pi would be over here, negative 3 pi would be the next one, okay, and so on. Now, since we said that cosine is just a shift of the sine graph by pi over 2 units, then it makes sense that the x-intercepts for cosine are just multiples of pi over 2, okay, or odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, okay, 9 pi over 2, and so on. All right, now when we go ahead to graph sine and cosine, obviously we understand that there's a general pattern here, this just kind of repeating, okay, up and down, up and down, up and down. So when we go to graph it, the first thing that we're going to take a look at is the amplitude and the period. Okay, that's going to help us set up our graph. So what we know is we know that every graph is going to look like this. Okay, it's going to be, we're going to start at the y-axis and then we're going to go out to a certain value out here for one cycle. Okay, we also know that we're going to have a certain amplitude, okay, up and down. So when we're graphing functions of the form y equals a times the sine of bx or a times the cosine of bx, then the amplitude is just given by the absolute value of a. So whatever number is in front, okay, multiplied by sine of x or cosine of x is the amplitude. So we're going to go up a units and down a units. And that's going to help you set up your graph. So that's going to tell you where your maximums and minimums are. Then to find the period, okay, we take 2 pi divided by b. So that'll be out here. So 2 pi over b will be that mark. And then, right, we're going to have a mark in the middle, okay, and then halfway between there again and halfway between there. And that's how you're going to always set up your graph for sine and cosine. It's by using those two. Now, once you have the axes set up, okay, then to graph, you're basically just going to use 5 key values, okay, 5 key points. So the first 3 are going to be the x-intercepts. Okay, so you're going to have an x-intercept. If you're doing sine, okay, you're going to start at an x-intercept. Okay, then at the end you're going to be back at an x-intercept, and then right in the middle you're going to have an x-intercept. Okay, if you're graphing cosine, okay, then your x-intercepts will be at the 1/4 way and 3/4 of the way through the cycle. Right, then the other points that you're going to graph for sine would be the maximum and minimum. So you've got a maximum here halfway between the first 2 x-intercepts. Okay, you've got a minimum in between the second 2 x-intercepts. For cosine, you're going to start at a maximum, you're going to end at a maximum, and halfway you're going to be at a minimum. So again, you can see for either graph you're going to have 5 key points. For sine, it's going to be 3 x-intercepts, 1 max, 1 min. So here, 3 x-intercepts, 1 max, 1 min. Okay, those are your 5 key points. When you graph cosine, you're going to have 2 x-intercepts, you're going to have 2 maxes, and you're going to have 1 min. All right, so 5 key points is going to help you create our kind of repeating wave pattern here. So let's get a couple examples. Okay, y equals 4 times the sine of x. Okay, if I want to graph that, again we have y equals a sine of bx. So a is 4 and b is 1. So my amplitude is going to equal 4. My period is going to equal 2 pi over 1, so just 2 pi. So when I set up my axes, okay, I'm going to have a maximum value of 4. I'm going to have a minimum value of negative 4. Okay, my ending point is going to be at 2 pi. Okay, I'm going to have a point halfway in between, and then halfway in between there, and halfway in between there. All right, now since it's sine, now if you can never remember, okay, sometimes it's hard for people to remember. Do I start at 0 or do I start here at 0 right here, okay, or do I start up here at the maximum? Okay, because cosine starts at 1 and sine starts at the other. Okay, so people have a tough time remembering, okay, which is which. So again, the easy way to remember which is go back to your unit circle. Okay, go out to this point right here, and remember that the points on the unit circle are cosine, sine. Cosine and sine. All right, so the coordinates of that point would be 1, 0. So you can see cosine starts at 1, sine starts at 0. So since we're graphing a sine function here, okay, we're going to want to start at 0. So that means we're going to end at 0, and we're going to be at 0 halfway in between. We go up to a maximum first. Okay, we go down to a minimum over here. So we plot those 5 key points, and then we just draw a smooth curve, okay, that goes in that wave pattern. And that's it. That's all there is to graphing these. Again, because there's such a unique pattern to these, okay, all we have to do is identify those few key things, and we can graph any one of these sine or cosine functions. All right, moving over to the second one, b. Okay, y equals cosine 4x. Okay, here a is 1 and b is 4. So the amplitude is going to equal 1. The period length is going to be 2 pi divided by 4, which is pi over 2. All right, so when I go to set up my scale on my axes here, I'm going to go up to 1, down to negative 1. My ending point is going to be pi over 2. And then I'm going to have a middle point, okay, fourth and 3/4 points like that. And then I'm going to plot my key points. All right, so again, since this is cosine, right, again, go back up to the unit circle. Cosine is going to start at 1, the maximum. Okay, that means I'm going to also end at the maximum. Okay, halfway in between, I'll be at the minimum. And then halfway between those, I'll be at my x-intercepts. Okay, so I've got my 5 key points, and now again, it's just a matter of drawing the smooth curve through those. And there's your graph of that. All right, so that's all there is to it. Okay, when you graph sine and cosine functions, okay, it's a matter of identifying your amplitude and your period to help you set up your axes, and then using those 5 key points. Okay, so sine, you start and end at the x-intercept. Okay, cosine, you start and end at the maximum. So from there, you should be able to figure out where the other points go. All right, well, that's it for sine and cosine. Okay, second part will be on tangent graphs. See you there.